Very good evening to one and all gathered here. Today we are going to see about the basic fundamentals of heat and mass transfer. So in today's learning objective, we are going to discuss what are the different physical mode of heat transfer and its type, how to perform an energy balance to determine the temperature and the heat flux when the heat is transmitted from one medium to another medium, then calculating the thermal resistance. So these are the learning objectives of today's session. So in this direction, now we are going to get into the basic fundamental concepts of heat transfer. So we all know that from the basic law of thermodynamics, heat is a mechanical phenomenon which transfers the energy from one medium to another medium by means of a temperature difference. So due to the change in temperature variation, the heat can be transferred mechanically from one phase to another phase. As per the science of thermodynamics, heat transfer is one of the main basic important parameter in order to conduct any mechanical process successfully. Say for example, heat transfer inside the engine cylinder during the power stroke or combustion stroke when the piston moves from PDC to TDC. So how much amount of heat is being generated during the power stroke? So this kind of study we call as heat and mass transfer. What are the different applications of heat transfer? You take a nuclear power plant component, you take a condenser, cooling tower, evaporator. So these are the main thing that will present in the nuclear power plant. Same thing for thermal power plant also. Okay, so you take both the example that involves heat engines. You take a boiler. Okay, so from boiler we can produce steam by heating the coal. Okay, by producing the gas. So the gas has been evaporated and that will be converted into steam. So here also we can able to understand the mechanism of heat transfer from one point to another point. The next example, the concept of heat transfer, metal treatment, treating the metal to change the properties, say mechanical properties, you say hardness, strength, etc. So there also we are passing the heat to remove all the defects present in the metal. So heat transfer is a very broad area of application that can be understood by these basic simple examples. Now let us go to the types of heat transfer. Conduction, next one is convection, and the last one radiation. You will see the different modes of heat transfer, the next consecutive information as given here. First, let us go with conduction. So, conduction is one mode of heat transfer, and that is considered to be the initial stage. Okay, so the heat is transferred from one part of the substance to another part by keeping close physical contact with each other. So what are the possibilities of heat conduction? Heat is produced by bombarding the atom, the gas molecules which has small micro atoms. Okay, so by vibrating the atoms, we can able to pass the heat between the two atoms are present inside the gas molecule, and we can able to freely transport the electrons by heat transfer through conduction. So to understand what is conduction, let us have some the derivative equation, Fourier law of heat conduction. So what is exactly mean by that? So that conductive heat transfer, you take a simple homogeneous solid body that is proportional, directly proportional to the area of cross section with respect to the direction of heat flow, and change in temperature between the two faces of the object, and also inversely proportional to the thickness of the slab. So this relation can be mathematically denoted Q. Q is the heat flow through the body with respect to a given unit time. So Q is directly proportional to the surface area of the heat flow and the change in temperature difference between the two faces of the block, and with respect to the change in thickness of the, not change in thickness, with respect to the thickness of the body according to the direction of the heat flow. So this can be defined mathematically. Q is directly proportional to A into dt by dx. So to remove the proportionality constant, to remove the proportionality, uh, the constant is introduced here. So Q is equal to K into A dt by dx, where K is the thermal conductivity. That is the proportionality constant used in the Fourier law of heat conduction equation. So when you increase the thickness of the slab, so that denotes negative symbol. So that leads to decrease in temperature due to the large thickness of the slab. When the heat is transferred in a large thickness slab, so it is a negative heat transfer. At the same side, you take a positive sign. So we call that as a positive heat conduction due to the reduction in the thickness of the slab. So we can able to increase the heat transfer by increasing the heating temperature from one phase of the slab to another phase of the slab. So depending on the amount of thickness variation, so this plus and the negative sign that is denoted in the above equation. So what is meant by thermal conductivity? The amount of heat generation through a body of a given unit area with respect to the thickness in unit time based on the temperature variation between the two adjacent faces of an object. So thermal conductivity is nothing but the amount of energy produced with respect to a given unit area of an object based on the thickness and also the temperature maintained between the two adjacent faces of the object. So this is the unit which is maintained for thermal conductivity. W per meter Kelvin. W is the watt energy per meter Kelvin. So meter is nothing but the area in which the heat is going to be distributed, transferred. And due to the heat, so temperature difference that is measured in Kelvin. Now, basic law of governing convection, next mode of heat transfer. So conduction we have seen. Now next second one is convection. So the energy transfer takes place across the system boundary due to the temperature difference by combined mechanism of intermolecular interaction and the bulk transport. The convection needs a fluid matter. So the heat transfer made to pass between the rigid wall and the fluid medium. So as per Newton law of cooling, Q is equal to H into A into delta T, where Q is the heat flow from the surface of the given medium. H is the heat transfer coefficient, and A suffix S is the surface area from which the convection is occurred. Then delta T is the change in temperature, surrounding temperature. That is Ts is the surface temperature, and T infinity is the surrounding environment temperature. So basic law of governing radiation. The next third phase of heat, different modes of heat transfer. As per the Stephen Boltzmann law theory, the amount of energy which is radiated by a given body is proportional to the fourth power of the absolute temperature and its surface area. So heat transfer Q is equal to, so epsilon, that is the surface emissivity. So the amount of heat which is radiated out of the surface, that can be defined by epsilon, where sigma is the Stephen Boltzmann constant, A is the given surface area, and T suffix S is the absolute temperature, and T suffix SUR, that is the surrounding temperature, environment temperature. So this is given as a fourth power of absolute temperature and the surface area. So this can be mathematically given in this formula equation. The heat that is radiated from the surface with respect to the given environment surrounding, okay, on a given area. So that is defined here by an equation, empirical equation. So with this lecture, I thank each and every one of you for the basic fundamentals on heat and mass transfer. So in the next meeting, we will discuss some other interesting topic in basic mechanical engineering specialization. So thank you very much for your kind support. So kindly forward the link to your close relative friend circle. So thank you one and all.